Hi dear students, welcome to Passiontronics, my YouTube channel. This is Dr. Ashok Jadhav, Head Department of Electronics, DSM College, Parbhani. Today this is introductory lecture, first lecture for first year class. Today I will introduce you with atomic particle electron, then flow of electrons through various materials. That is, electronics is the branch of science that deals with the atomic particle electron, its motion through various material, control flow of electron through various materials, evolution of various electronic devices, and application of various electronics devices. In short, electronics is the major part of modern science. So let us study one by one. Friends, let us discuss some historical aspects, historical perspective of electricity and electronics. As you can see here in this slide, the discovery of electricity goes as back as 600 BC, and then Greek people were aware of that when the bird's fur is rubbed against that amber. Amber is a like a gum-like material from the forsyth tree, and if it is rubbed against that amber, that caused an attraction, and that was the first event or incidence of, you can say, electricity, and that was the example of static electricity. And then in 1752, Benjamin Franklin, United States physicist and chemist, proved that lightning and tiny electric sparks were same. He did several experiments on when there were laden clouds come to very close to Earth, and there was some sort of electrical discharge. And he did several experiments using the kite and other things, and many people got electric shock in those days, and he just proved that is lightning and that tiny electric spark we observe today, they were same. Then in 1800, Italian physicist Volta, who developed the chemical cell, and this Volta was the first person to create steady flow of current. So he developed the cell, and today it is known as Volta's cell. Then actually this is very interesting. We have been using electricity prior to discovery of electron. Then we didn't know that there exists electron, and that is the atomic particle, and interestingly that electron is the same in all the atoms. We didn't know then, but still we used electricity then. Then in 1831, Michael Faraday, who was from the United Kingdom, England, invented electric dynamo by using some magnets and the coil, and he could generate some voltage, and electricity first time becomes viable. Viable in the sense it came to exist, and they could use on experimental basis. And later in then 1878, Thomson Edison from United States and Joseph Swan from United Kingdom, they invented incandescent light bulb. You have seen the bulb with the filament, and when it is applied with electricity, that filaments gets heated and it radiates some light. That is called incandescent lamp, and that is the discovery of, or you can say bulb is the invention invented by Thomas Edison and Joseph Swan separately. And then comes in 1897, 1897, when J.J. Thomson discovered atomic particle electrons. So what he said then, that the electric current is nothing but flow of electrons, and he was from the United Kingdom. Then in 1917, Rutherford from New Zealand, who gave, can say that, atomic model, and he said that atoms are nothing but uh, mostly vacuum. It has a tiny electrons orbiting some nucleus, and almost all the mass of the atom is concentrated at the nucleus. That was the hypothesis by Rutherford, and he gave a good atomic model. Today we are using it. And later, Bohr was a Danish physicist who gave the stability to that model proposed by the Rutherford. Actually, you have studied Bohr theory last year. So this you can say that these are some important milestones in the discoveries of these electricity and electron. Let us see. Here I have shown this picture of one atom. At this center, this is a nucleus, and we have the first orbit, second orbit, third orbit, fourth orbit, and so on. These on this circular elliptical, we have the dots. This dot indicates electron. Electrons are the atomic particle, and they have the negative charge. They revolve around this nucleus. Nucleus has a positive charge, and total negative charge on all these electrons is equal to the total positive charge of the nucleus, and therefore electrically atom as a whole has a zero charge. All you have studied. Now let us discuss the size of this atom and size of nucleus. If you consider outermost orbit, that is the size of atomic structure, and you know that you have studied atomic size is about 10 raised to minus 10 meter, and the nucleus is about 10 raised to minus 15. So nucleus is very small. Just for example, I have drawn here, I have shown here two images. This is the very famous image of pyramid, Egyptian pyramid, and this is, you know, the fruit everyone likes, apple. So if you consider the size of this pyramid as the size of atom, the nucleus has the size of just an apple, and see the difference. In short, I can say that this nucleus and atom, atomic size is about 10 raised to 5 larger than the nucleus, 1 lakh times more than that of nucleus. So in an atom, mostly you can see that we have the space, okay, and this model is given by Rutherford and supported by the Bohr theory, right? In any conductors or in materials, for example, if you consider the conductor, in conductor, what are the conductors actually? The conductors are the material in which that atom has one, two, that means less than 3 electrons in outermost orbit. Atomic structure of all conductors says that outermost orbit has less than 3 electrons, and because of that these electrons are very loosely bound with nucleus, and therefore with slightest energy, external energy, this electron leave the atom and they can move from atom to atom. When slight energy is applied to such material, electrons can be made to move. So here this is the picture of, say, isolated conductor. Isolated conductor means it is not connected here. At room temperature, these red dots are the electrons. They move randomly in all possible direction from one atom to other atom, and all the directions are random, but they don't leave the conductor. What is a conductor? Actually, these are the materials where electrons can move easily through that material. That is conductors. So this is a picture of conductor, and you can see that the billions and billions of electrons, they are moving randomly. For example, if you consider a cross-sectional area here, the number of electrons going from the left to right or from right to left are equal, and therefore the net electronic flow across that cross section area will be 0, and that's why we say that when conductor is isolated, there is no electrical current through the conductor. So you can see here, in conductors, electrons are loosely bound with nucleus. At room temperature, electrons move randomly in all the direction. No net electron flows across the cross-sectional area, and therefore there is no current in conductor when not connected to any source. No external energy is applied here, only room temperature, thermal energy is here. But with slightest external force can make them move and flow, and that is the current. So when electrons flow, you get the current. So current is nothing but rate of flow of electrons. So now the same conductor, if you connect a small electrical voltage source, we call this as a cell, and it has a stored form of energy, right? Positive terminal has ability to attract electrons, and negative terminal has energy to repel electrons, because stored form of energy is there. That is the feature of that electrical source, right? Now this positive terminal, this straight line indicates the best conductor wire. Straight line is best conductor wire, and this is piece of large, you can say large conductor, and this negative sign indicates that are electrons, free electrons available in that piece of conductor. So because of application of this voltage, volt is the unit used to measure that source energy, right? And now this positive terminal attracts the electron, and this negative terminal repels the electron. So one electron goes from the negative terminal, enter in the conductor. At the same time, one electron leaves this conductor, and so on. So if there are 10 billion electrons entered into conductor, 10 billion electrons leave the conductor. And as these electrons charges move, that sets up current. And this is how we get the electric current, right? So current, rate of flow of electrons is called the current. It is measured in coulombs per second. Coulomb is the name of scientist, and his name is given to this electric current, right? This unit is given the name as ampere. This is also called ampere. Ampere is again name of other scientist. So 1 coulomb per second is nothing but 1 ampere current. And the coulomb is defined, 1 coulomb is defined, and therefore this electronic charge is 1.6 into 10 raised to minus 19 coulomb, or in 1 coulomb we have these many electrons, 6.4 into 10 raised to 18 electron. This is very huge figure. So if these many electrons come together, that constitutes 1 coulomb charge. Just for an example, अगर ये देखना है 1 कूलम में कितने इलेक्ट्रॉन्स है, तो मान लीजिए एग्जांपल, अगर आपको ये इलेक्ट्रॉन्स मेजर करने, काउंट करने कितने हैं, जैसे काउंट करते ना अपन 1 2 3 4 10 100 1000 लाइक दैट. सपोज यू आर काउंटिंग, आप ये इसकी गिनती कर रहे 1 कूलम में कितने इलेक्ट्रॉन हैं, और आप बहुत स्मार्ट है, आप गिफ्टेड है, आप 1 सेकेंड में 1000 इलेक्ट्रॉन मेजर कर सकते, काउंट कर सकते हैं. दिस इज हाइपोथेटिकल एग्जांपल. आप में क्षमता है कि आप 1 सेकेंड में 1000 इलेक्ट्रॉन काउंट कर सकते हैं. तो 1 कूलम में जितने इलेक्ट्रॉन है वो काउंट करने के लिए आपको 190 मिलियंस लगेंगे, 190 10 लाख वर्ष, 190 millions year, and you know that average life of human is just 60 70 80 years, right? So nobody can count physically these many electrons, right? सो 1 एम्पियर करंट मीन्स अगर उस कंडक्टर में से 1 कूलम चार्ज 1 सेकेंड में जाता है तो उस कंडक्टर में 1 एम्पियर करंट. सो 1 एम्पियर करंट इज वेरी लार्ज अमाउंट. ओके, सो let us study. From this point our syllabus begins. Ohm's law. And actually this lecture is a repetition. Actually you know Ohm's law, you might have studied in 11th and 12th class, right? Ohm's law, again here Ohm's is the name of the given scientist as an honor, right? The statement of the Ohm's law. You see, before going to the statement, this is a source, battery, stored form of energy. It has ability to accept charge and give the charge, right? Then it is connected by wire to this zigzag component. This is the symbol for resistor. Zigzag means electrons cannot move through that part easily. It is a opposition, that's why it is called the resistor, right? So this component is called as the resistance. This is the battery, and then because of this external source, this is a conductor having certain resistance, and electron will flow from the negative terminal to the positive terminal. That sets up the current, and current is measured by an ammeter. So there is a meter having pointer that is connected in the path in series to record the current. अगर करंट जाता है हाँ या नहीं और जाता है तो कितना जाता है ये मीटर दिखाएगा. और ये रजिस्टर के अक्रॉस इस बैटरी की वजह से कितना वोल्टेज डिफरेंस आ रहा है तो वो मेजर करने के लिए यहाँ हमें वोल्ट मीटर कनेक्ट किया अक्रॉस द रजिस्टर. तो ओम्स, अकॉर्डिंग टू ओम्स लॉ, व्हाट इट सेज, इन अ सर्किट विथ डीसी वोल्टेज सोर्स, दिस इज द सर्किट. व्हाट इज सर्किट? इट इज एन अरेंजमेंट ऑफ सेवरल कंपोनेंट्स कनेक्टेड टुगेदर फॉर सम स्पेसिफिक पर्पस. खास हेतु के लिए कनेक्ट किए हुए एक्टिव एंड पैसिव कंपोनेंट, दैट इज द सर्किट. इन अ सर्किट विद डीसी वोल्टेज सोर्स, the current flowing through a conductor, this conductor is directly proportional to the voltage potential difference applied, right? मतलब ये फिगर में देखें, इसमें से जाने वाला करंट ए, इट इज अ प्रोपोर्शनल, सम प्रमाण में है किसके? ये वोल्टेज के. सो करंट इज डायरेक्टली प्रोपोर्शनल टू वोल्टेज. इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि अगर इसका मतलब ये है कि अगर हम वोल्टेज बढ़ाएंगे तो करंट बढ़ता है, और वोल्टेज को कम करते हैं तो करंट विल डिक्रीज. सो दिस इज कॉल्ड एज current is directly proportional to volt. This is the first part, half part of the Ohm's law. And the second part here, and current is inversely proportional to the opposition in the path. जिस पाथ से वो इलेक्ट्रॉन्स जा रहे हैं, जिस पाथ से वो करंट जा रहा है, वो व्यस्त प्रमाण में रेजिस्टेंस के अपोजिट. सो करंट इज इनवर्सली प्रोपोर्शनल टू आर. तो इसका मतलब क्या होता है? अगर हम रेजिस्टर को बढ़ाते हैं तो करंट कम होगा, और रेजिस्टर को कम करते हैं तो करंट बढ़ता है. दिस इज कॉल्ड इनवर्सली प्रोपोर्शनल. सो करंट इज इनवर्सली प्रोपोर्शनल टू रेजिस्टर. सो बाय कंबाइनिंग दिस टू and having some same system of units, you can write current is equal to voltage upon resistance. So this is a formulation of Ohm's law, and you should remember this formula. This is the first and foremost step in physics or electronics. Without knowing this formula, you cannot study electricity or electronics. And what this formula tells, this sign of equal to means a left hand side is equal to right hand side. अब ये करंट है, करंट इक्वल टू है वोल्टेज अपॉन रेजिस्टेंस है, और जो न्यूमरेटर में रहता है ना उसके साथ वो डायरेक्टली प्रोपोर्शनल में रहता है, और जो डिनोमिनेटर रहता है उससे वो इनवर्सली प्रोपोर्शनल रहता है. सो दिस रिलेशन बिटवीन अप्लाइड वोल्टेज एंड रिजल्टिंग करंट इज नोन एज Ohm's law. तो ये statement or a formula is nothing but the Ohm's law. And from this basic formula, you can get the three variations of Ohm's law. I equal to V by R. This is basic. Then from this formula, you can generate resistance, opposition of the path is equal to voltage upon the current. And the voltage drop across the resistor can be given as product of current flowing through that conductor and resistance. मतलब ये जो वोल्टेज मेजर कर रहा है ये कितना आएगा, इसमें से जाने वाला ये जो करंट है यहाँ, so this current multiplied by this resistor. So these relations improves our understanding of behavior of circuit. Circuit कैसे काम करता है और इसकी अंडरस्टैंडिंग बढ़ जाती है. And in analysis, circuit analysis, we can find out value of one quantity if two are known without connecting the circuit and measurement. So without connecting circuit physically in the laboratory, you can estimate. अगर दो ऐसे मतलब उसमें से जाने वाला करंट इतना है, उससे इसके अक्रॉस में इतना वोल्टेज आता है, तो you can predict what is the resistance of that, is it right? So in order to improve your understanding about the Ohm's law, let us consider one more example. We call this as a water flow analogy for Ohm's law. This example, I am sure that this example will improve your understanding of the voltage, current and resistance concept. Look at this. Here, see, this is a water tank, overhead water tank, और ये है ground, and this is the height, this much is the height of this water tank, and here water level is like this. Suppose H is the water level from the ground, and this pipe is connected here, and suppose this pipe is open, outlet is at ground level, okay. This is the level, height, water is filled up to H, and there is an open pipe here. Will there be any flow? Obviously, there will be water flow. Why? Because water always flows from high level to low level, high gravitational potential to low gravitational potential. As you go away from the earth center, the gravitational potential increases. Okay, and therefore, because of that particular level, here some water will flow through this pipe. Let us call this discharge as Q. Q means number of liters flowing per second. Say for example, 5 liters per second is the discharge, for example, right? Now, for this height H, you have the discharge Q, okay. But now, if I increase this water level to some high level for the same pipe, पाइप वही रखना है, लेकिन ये वाटर लेवल हमने यहाँ तक बढ़ाई है. मतलब अब जो है हाइट is H dash. Now imagine for the same pipe water level is more, then you can imagine and can predict what could be the discharge. Let us call that discharge as a Q. Now compare this. Is this Q dash greater than this earlier or less than or equal to? ये टैग में वाटर लेवल बढ़ाने से सेम पाइप से ज़्यादा पानी जाएगा या कम पानी जाएगा? Naturally, as the level increases, the pressure will increase and the large discharge will be there. So with more height, you got more discharge. And see that this discharge, ये देखो, ये हाइट को ये डिस्चार्ज, ये हाइट को ये डिस्चार्ज, You can say that if height is increasing, the discharge, that is current, water current will be more. If height is increasing, water current will be more. If H is decreased, the discharge will decrease. It means that water flow discharge is proportional to H. So this is like our current and this is like our electrical pressure. मतलब ये ग्रेविटेशनल पोटेंशियल बढ़ाया तो वो पाइप से जाने वाला लिक्विड फ्लो, वाटर फ्लो विल बी मोर. So in the same way, in case of electricity, current is directly proportional to the voltage. That means अगर ये voltage बढ़ता है तो current बढ़ेगा, voltage कम होता है तो current कम होगा, right? So this is the first part you can see here, right? Then अब सिचुएशन ऐसे देखना है, मान लीजिए ये हाइट कांस्टेंट रखना है, कांस्टेंट टू एच लेवल, और पाइप से छेड़ना है, पाइप कम ज़्यादा करना है, पाइप की डायमीटर कम ज़्यादा करना है. नाउ फॉर सेम लेवल द पाइप E gives discharge Q. Now for same water level, now if I increase the pipe size, for the same height, what will happen? Now I have changed the pipe size to B and therefore discharge will be Q, and you can say that the discharge in second case will be greater than the first case. मतलब सेम वाटर लेवल के लिए अगर हम बड़े डायमीटर का पाइप लगाएंगे तो उस पाइप से ज़्यादा पानी जाता है. क्यों? बिकॉज ऑफ मोर डायमीटर देयर विल बी लेस अपोजिशन टू फ्लो. वो फ्लो को जो प्रतिरोध है वो कम हो गया, दैट इज रेजिस्टेंस कम हो गया, and that's why the more current. That means this current here, water current, is inversely proportional to the opposition, and this is how mathematically we write 1 by R. इसका मतलब क्या है? ये डिनोमिनेटर अपोजिशन बढ़ गया तो करंट कम होगा, अपोजिशन कम कर दिया मतलब डायमीटर बढ़ा दिया, कम कर दिया तो करंट बढ़ेगा. इससे उल्टा भी आप सोच सकते हैं. अब ये नॉर्मल पाइप है तो एच लेवल कांस्टेंट है, पाइप ए का डिस्चार्ज है क्यू. मान लीजिए हमने इस पाइप को रिप्लेस किया, बहुत छोटा पाइप, छोटा मान लीजिए जैसे आपके बाल जैसा, वेरी थिन पाइप थी, बहुत ही छोटा डायमीटर. For same height, I have replaced this pipe with a very small, low diameter pipe. Can you predict the water flow through this pipe? For the same height, now pipe is B, and here the discharge will be naturally less than Q. Why? With this small pipe, you will get the low discharge, low water flow, low current, because the opposition has increased. Opposition to water flow has increased, and therefore you can say that current is inversely proportional to opposition. So this water analogy is like this. This water height is nothing but the electrical pressure, that is voltage, and this rate of flow of water is analogous to our current, number of electrons, rate of flow of electrons. So here you get the idea of gravitational potential, electrical potential, water discharge as a current, flow of electrons. So this is about that is water flow analogy. Now here this is the funny picture. This is a, you see, a picture representation of Ohm's law. See that this is the pipe. You see here, this is the pipe through which current flows. This is the pipe, okay. This is the pipe, right? And this is the current. This fellow represent the ampere, that means this is the current, right? और ये करंट क्यों आता है? पहले वोल्टेज की करंट, पहले वोल्टेज चाहिए. सो विदाउट एनी सोर्स ऑफ एनर्जी देयर कैन नॉट बी एनी एक्शन. ये वोल्टेज इसको मजबूर करता है फ्लो होने के लिए, दैट्स व्हाई धक्का, पुशिंग. और ये बीच में ये जो फेलो है, इट इज रिप्रेजेंटिंग ओम्स अपोजिशन. नाउ इसने अगर ज़्यादा खींचा यहाँ, तो इसका जो डायमीटर ये कम होते जाएगा. हाँ, दैट विल अपोज द करंट. तो करंट दो चीज़ के ऊपर है. ये एनर्जी का सोर्स जितना बड़ा उतना करंट ज़्यादा, मतलब जितना वोल्टेज ज़्यादा उतना करंट बड़ा. और इसके साथ ये भी है, वो जितना रेजिस्टेंस जितना ज़्यादा खींचेगा यहाँ, तो उतना करंट कम होगा. इट मीन दैट द फर्स्ट पार्ट इज current is directly proportional to voltage, and second part is current is inversely proportional to resistance. And therefore you always remember this, V equal to V by R. This is the Ohm's law, right? Yes, wait, here previous one. How to remember this? This is a circular presentation, and all the three formulas can be remembered here, right? So I will take this away here. Now if you want expression for the V, अगर आपको V है, इसके ऊपर हाथ रखो. V के लिए फिर बाकी दोनों देखो कैसे आएगा. I adjacent R, तो IR. So V is equal to IR, right? And suppose आपको I देखना है, ये I चाहिए आपको, ये I. तो इसके ऊपर थंब रखो, इसको ढक दो, तो I कैसे मिलेगा आपको? V बाय R. I कैसे मिलेगा? V बाय R. और अगर आपको ये चाहिए, R चाहिए, तो इसके ऊपर थंब रखो, इसको ढक दो, तो R is given by V upon I. So all these three formulae can be easily memorized if you draw this simple diagram. ये डायग्राम आप इसको सिंपल याद रखेंगे. सर्कल ड्रॉ करना है, ऊपर V लिखना है या IR लिखना है, फिनिश. तो इसमें से इफ यू हैव एनी कंफ्यूजन, you can draw this figure and instantly get it clear, right? So let us consider the next page. And here this is how you can study the Ohm's law in the laboratory also practically. अगर आप इसको वेरीफाई करना है, तो यहाँ रेजिस्टेंस लगाओ, यहाँ बैटरी लगाओ. ये वेरिएबल का मतलब you can vary this voltage for a given resistance, and here you can record. यहाँ आप करंट और वोल्टेज रिकॉर्ड कर सकते हैं. Let me take a pen here. So here, तो यहाँ आपको मिलेगा एमीटर, यहाँ करंट मिलेगा और यहाँ मिलेगा वोल्टेज. तो हमने यहाँ जो मिलता है वोल्टेज और ये करंट, और दिस एरो इंडिकेट्स दैट दिस सोर्स इज वेरिएबल. तो देखो भाई, दिस इज अ टेबुलेशन ऑफ रीडिंग. हियर व्हेन द वोल्टेज इज जीरो, दैट मीन्स नो एक्सटर्नल एनर्जी सोर्स. In that case, current is going to be zero. No current will flow. Now I have increased this voltage, so I have made this plus minus. Now this is a 2 volt. तो कुछ करंट आ रहा है. कितना आ रहा है? 1 मिली एम्पियर. करंट का यूनिट है एम्पियर. मिली मतलब 1000 part of that. Okay. And if I now make this as a 4, for 4 volt, you get a 2 milliampere, and so on. You increase this voltage, current increases. Increase this voltage, current increases. Increase this voltage, current increases. What is this actually? voltage across the resistance and the current flowing through the resistance. So this is table gives applied voltage and resulting current. See that this is we apply and this is what this is the cause and this is effect. Voltage is the cause and the current flowing is the effect of that. And again you can draw this and see what we get here. Here this is a origin. We have taken voltage on x-axis 2, 4, 6, 8 volts, and here we have taken the current, and then we get our first point. For 2 volt it is 1 volt, for 4 volt it is 2 milliampere, for 6 volt it is a 3 milliampere, and for 8 it is 4 milliampere, for 10 it is a 5 milliampere, and for 12 you get a 6, and then by joining this you get this straight line structure. Remember that in a graphical, this is a actually graphical representation of Ohm's law. And in a graphical, if we have the straight line relationship between x quantity and y quantity, this straight line indicates they are proportional to each other, and this line indicates that the effect is directly proportional to the cause. Current is directly proportional to voltage. So this is all about the Ohm's law. And what is the Ohm's law? You know that it can be used for circuit analysis. It is time to stop here. See you next time with new concept. Bye.